Okay folks, this is part one of my Ikea RGB mood lamp, and the first thing I'm going to do is, because I know that the RGB LED, this little widget here, gets very hot, I'm going to attach it to a heatsink. Now this is the heatsink out of an old Xbox. It's the GPU heatsink, and all I've done is I've just simply cut it in half with a hacksaw, junior hacksaw, and I've just roughened the surface up a little bit. Now it will be very difficult to actually affix this on here, so what I'm going to do is I'm going to use heatsink compound made from a two-part epoxy resin, i.e. araldite, and this stuff here, which is aluminium powder, which you can purchase on eBay, and I use for making silver paint as well as other things, mentioning nothing, like thermite for example. So there's the LED. I'm going to mix some of this up now. I shall be back in a second. Okay, there's a couple of small blobs of epoxy and some aluminium powder. I'm just going to give that a quick mix. This is a very good solution for anything where you need a strong thermally conductive bond. I've used this technique for repairing and attaching heat sinks to a variety of items, and it goes to a lovely thick paste. This is a very quick setting epoxy resin, because I'm not the most patient man. Okay, and there we go. Now this araldite, this is B&Q's araldite. It sets in about 2 minutes flat. Right, so I'm just going to smear just on the back of the LED. I'm just going to put a thin coat of my thermal transfer compound. So all we're trying to do is to achieve a good thermal transfer. I tested one of these LEDs last night on my sort of first prototype, and the LED was running at 70 degrees C. Now that was after about 10 minutes, so as you can imagine, if it's running for even longer, it's going to get hotter and hotter and hotter, and the maximum recommended temperature for this LED is 55 degrees C. So I decided to use a bigger heatsink. Okay, so here we go. I'm just going to plop that in the middle there, give it a little squeeze, and there we go. Within a few minutes that will have set, and hopefully that heatsink is much more substantial. I've even thought about using a small fan on this thing to keep it even cooler, but we'll see how the temperature goes with this one. The next thing I'm going to do with this, because of how I'm arranging the wires, I'm going to put a layer of insulation here on the bottom half so that I can run the wires down and there's no danger of them touching on the heatsink and shorting it out. Okay, so that's the LED for my RGB mode lamp. I'll see you in part 2. Okay folks, that's the completed assembly. What I've actually done is, just on the bottom, just here, I've put a layer of araldite, a couple of millimeters thick. It's probably quite difficult to see, but all that's going to do is it's just going to act as an insulator for the cables. Because of how this stands up, it's using the wire on these large high power resistors. These are 3-watt wire wound resistors. The wire on them is very stiff, so I'm using that to actually act as a support for the LED and the heatsink once it's inside the lamp, as it needs to be manipulated in, and it makes it much easier than having to mess around with really thin flexible wire. This thing, it's a 3-watt LED, so it doesn't draw a great deal of current to be fair, but that's the best way that I've discovered of doing it. So I'm just going to let that set, and then I'm going to wire it up to the test circuit, and I'm going to run some temperature tests and see what the resulting temperature's like. So I'll join you again shortly. Okay folks, this is actually the circuit itself with my test LED on. It's a very, very simple circuit, and it's come from a website called bigclive.com. Guy's an absolute wonder, very, very helpful. Circuit's about £17, they are available on eBay. LEDs about £10, resistors about 40p each, and this is being powered off a 5-volt supply. As you can see, there's a small pick on the circuit board and 2 switches for the programs, which are just standard press switches. That was the heatsink I was using originally. Now the temperature gets well up to 70 degrees C, which is too hot. So the point of this, as you can see, if you look at the comparative size of the heatsink, it's way bigger, and I'm hoping that that should fetch the temperature round to around 55-60 degrees C. I haven't done any maths on it, it's purely educated guesswork. So I'm just warming the soldering iron up, and I'm going to convert, I'm going to swap this LED here for the one on the new heatsink, and then I'm going to run some temperature tests. So I'll see you very shortly. Okay folks, there we go. That's the completed circuit with the LED, the resistors, the new heatsink, and I've also just put the switches from that side of the board to that side of the board. As it sits in something with the copper side of the PCB face up, obviously it makes it much easier to depress the switches. So what we'll do now is we'll power it up, and we'll see what happens. I suppose it'll either work or it'll explode in my face. Okay, here we go. And there we go. So I'm going to leave this running for a little bit. If you watch, you'll probably see the LED change. Yeah, there we go, look, from green to, I suppose, a whitey blue. And pushing the buttons on the other side of the PCB alters the sequence of colours, alters the colours that you see, etc. But what I'm more interested in is just obviously testing the temperature and looking out for any parts that are smoking, so to speak. So I'm going to leave this running for 10 minutes, and I will join you again shortly, and then I'll actually put it into the housing and you can see the thing in full effect. Okay folks, it hasn't been running that long, to be fair, but if you look at the temperature probe, I don't know whether you can see that's reading 48 degrees C, which is considerably less than it was running the other day. That's with the new super large heatsink on. I'm going to leave it running a little bit longer just to see what temperature it gets up to. The magic figure is 55 degrees C, that's the one I'm trying to avoid. So I'm going to leave that to run. I am actually going to put a really small fan on this heatsink. I've ordered some really tiny fans off eBay, and they should help keep it much cooler as well. So I'm just going to leave it to run for a bit.